Hello everyone, my name is Amareshwar Reddy from CSC Section A and my topic is about how does temperature affect the behavior of a PN junction diode. Introduction to PN junction diodes. A PN junction diode is an electronic component made by joining two types of semiconductor materials. One is P-type which has more positive charge carriers called holes and the other is N-type which has more negative charge carriers called electrons. When these two materials are connected, they form a junction that allows current to flow easily in one direction but blocks it in the other. This property makes diodes very useful in circuits for controlling the direction of current flows. So in simple terms, temperature changes how easily current flows through the diode. Understanding these effects helps engineers design circuits that work properly under different environmental conditions, ensuring reliability and safety. Next, the basic structure of a p-n junction diode. A diode is made up of two parts, a p region which has more positive charge carriers called holes and an n region which has more negative charge carriers called electrons. When the diode is forward biased, positive connected to p side and negative to n side, the barrier becomes smaller and current flows easily. When the diode is reverse biased, connections are reversed. The barrier becomes larger and almost no current flows. So the diode allows current to flow in only one direction. That's why it's often called a one-way switch for electricity. The effect of temperature on semiconductor materials. When the temperature increases, the atoms inside the diode get more energy. This extra energy makes it easier for some electrons to break free from their atoms and move around. As a result, more electrons and holes, the spaces left behind when electrons move, are created inside the material. Because of this, the number of charge carriers increases, which affects how electricity flows through the diode. In simple terms, a diode's electrical behavior changes with temperature. It can conduct more current when it gets warmer and its resistance decreases. However, if the temperature becomes too high, it might damage the diode or make it more improperly. Temperature and saturation current. When the temperature of diode increases, more energy is available for the atoms in the semiconductor. This extra energy causes more electrons and holes to be created inside the material. Because of this, the saturation current, which is the small current flowing through the diode, even when it is reverse biased, increases very quickly with temperature. As a result of the higher saturation current, the leakage current, the unwanted current that flows when the diode should ideally block current, also becomes larger. In simpler words, heating the diode makes it easier for small currents to pass through, even when the diode is supposed to be off. Forward bias behavior and temperature. In simpler words about this topic, we can say when the temperature goes up, a diode needs less voltage to allow the same amount of current to flow. So it starts conducting, turning on earlier or at a lower voltage. Reverse bias behavior and temperature. When the temperature increases, more charge carriers, electrons and holes are generated inside the diode. This makes the reverse saturation current go up. As a result, the small leakage current that flows when the diode is reverse biased becomes larger. Also, the diode may break down, conduct heavily in reverse at a lower voltage because high temperature weakens the junction barrier. Impact on diode efficiency and performance. When the temperature of a diode increases, more unwanted current starts flowing even when the diode is supposed to be off. This extra current causes power loss because some energy is wasted as heat. If the heat keeps building up and is not removed properly, the diode can get even hotter. This is known as thermal runaway. It, it's like a loop where heat causes more current and more current causes more heat, which can damage the diode. That's why good cooling or thermal management, like using sinks, like using heat sinks or proper ventilation, is very important to keep the diode working safely and reliably. Thermal generation of carriers. When the temperature increases, more heat energy is available inside the diode. This extra energy helps create more free electrons and holes inside the depletion region. As a result, there are more charge carriers available to move, which increases the current flow in the diode. This effect happens naturally due to the material's properties and does not depend on any external voltage applied. It's an internal or intrinsic process caused purely by heat. Changes in depletion layer width. The depletion layer in a diode becomes thinner, narrower. This happens because more electrons and holes get enough thermal energy to cross the junction. As a result, it becomes easier for charge carriers to move through the diode. This means the diode can conduct current more easily, especially in the forward direction. However, this also affects how the diode behaves in reverse bias as the leakage current increases. In simple terms, higher temperature makes the diode more conductive by reducing the barrier that normally resists current flow. Effect on breakdown voltage. When the temperature goes up, the breakdown voltage of both avalanche and Zener diodes becomes lower. This means the diode can break down at a smaller voltage than before. So higher temperatures make the diode less capable of handling large reverse voltages safely. Practical implications in circuit design. Electronic components like diodes, transistors, and ICs change their behavior when the temperature changes. For example, some may conduct more current when hot or require less voltage to operate. If designers ignore these effects, circuits can become unstable, malfunction, or even fail. To prevent this, the engineers use temperature compensation techniques. This can include adding extra components that adjust the circuit automatically as temperature changes, choosing materials that are less sensitive to heat, or designing circuits that naturally balance out temperature effects. Summary of temperature effects on a PN junction diode. When saturation and leakage current increases, what happens when a diode gets hotter? More charge carriers, electrons, and holes are created inside it. Effect. Even when the diode is reverse biased, blocking current, a tiny current called leakage current flows. As temperature rises, this leakage becomes larger. Simple analogy. Imagine a dam holding water at normal temperature. Only a tiny trickle leaks through. When it gets very hot, more cracks appear, so more leaks. Forward voltage decreases. What happens? To make a diode conduct current in the forward direction, you need a minimum voltage called forward voltage. Effects. As temperature rises, the diode needs less voltage to start conducting because the charge carriers move more easily. Simple analogy. Think of it as pushing a door. On a cold day, it's stiff. On a hot day, the hinges loosen, so it opens with less effort. Finally, the conclusion of this topic is temperature plays a very important role in how a PN junction diode behaves electrically. When the diode gets hotter, the extra heat gives more energy to the electrons and holes inside the semiconductor. This causes more charge carriers to be available, which changes how easily current can flow through the diode. For example, forward bias behavior. The voltage needed for the diode to conduct decreases as temperature rises, so the diode turns on at a slightly lower voltage. Reverse bias behavior. The leakage current increases with the temperature. Also, the breakdown voltage, the voltage at which the diode starts conducting a lot in reverse, usually decreases the heat. These changes can affect circuits if not considered. For instance, in sensitive electronics, a small change in diode current due to temperature can impact the whole circuit's performance. To handle this, engineers use temperature stable materials or specially designed diodes that are less sensitive to heat. Circuit design techniques like adding biasing arrangements or feedback circuits can compensate for temperature changes. Cooling methods like heat sinks or fans are often used to keep diodes from overheating. Advances in both materials like silicon carbide or gallium nitride diodes and small circuit designs helps reduce the negative effects of temperature, making electronics more reliable and efficient. If you want, I can also make a super simpler visual explanation showing how temperature affects a diode forward and reverse currents. It's really easy to understand at a glance. Thank you for uh, thank you for listening this topic.